Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of graphing functions and identifying features. This is standard A.3C in the great state of Texas, and we are using item number 35 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it. We will look at our answers together. All right, so we need a graph that has these two features. I'm going to write them on the side so we can keep our screen scroll down. We need a slope of 2/3, and then we need a y-intercept of 4. All right, so let's get those locked in. We can keep this scroll down. All right, so one thing we should notice is that both of these are positive, right? And so we can do this by just using just some basic observational tools without even really doing any calculation, right? So when we have a positive slope and a positive y-intercept, I always think, let's start here because I always think that y-intercept is going to be a little bit easier. The y-intercept is where the line crosses the y-axis, And so we're crossing it at +4. And so you see here, I'm crossing it +4, and there's no cross on this particular one. There is a cross on D. There is a cross on B. And close, but there is no cross on A. Actually, if you look at it, look at what A's got. A actually has an x-intercept of 4. And so does this one. This one has an x-intercept of 4. All right, so we need to obviously make sure we're tracking the y-intercept versus the x-intercept. And we notice that we have no y-intercept of 4 on A or on C. So we're down to 2. Now, when we're looking at our slope, sometimes we can just use positive or negative to let us know, and in this way we can. Sometimes we actually have to do a little bit of calculation, so I'll show you how that works as well. But a positive slope will move up. It might be steep, it might be shallow, but moving from left to right, a positive slope will move up. And then likewise, a negative slope will move down from left to right. So look at B and D. The only one that moves up is D. B is moving down, which means if it follows the rules that I just said, that's a negative slope. That's a positive slope. And since we have a positive 2/3, it is less than 1, but that doesn't matter. Then that looks like that's going to be it. Now, how do we verify? Well, let's take 2 points. I'll just take our 2 intercepts. So I've got an intercept at 0, 4. I also have an intercept at -6, 0, one for the y-axis, one for the x-axis. And let's use our slope formula, m equals y2 minus y1, x2, x1. We just want to make sure that we've labeled these correctly. So let's make this x1 and y1. It actually would work if we reverse those, as long as our x1 is always with our y1 and our x2 is always with our y2. So let's do 0 minus 4 over. Now, if that's going to be a negative, in order for it to be positive, my denominator needs to be negative as well. And I've got my x's, I've got -6 minus 0. So that ends up being -4 over -6, which is +2/3. All right, so that does check out. Another way that we could do it is we could say that for 2/3, right? So for every 3, so 2/3 means that for every 3 that we're going over, we're going up 2. So we could start here, and we can go over 3, 1, 2, 3, and we can go up 2, 1, 2, and it hits that line. And so that's another way to verify it. But that is pretty straightforward. B is not going to work because that's negative. It is sloping down. D is going to work. It's positive, and that's our answer.